So welcome to the afternoon session. I'd like to mention again, for those of you who've joined who may not have been here this morning, that Tom from our communications team is here to take some photos of the event, which we're going to use in publicity. We'd like to, and on social media. But if you don't want any photographs to appear, please let him or a member of the staff know. So, for those of you who weren't here at the AGM, I'm Philip Bloom, the outgoing chair, and it's my privilege to continue to chair the rest of this meeting until the Q&A at the end, which I'll co-chair with Tony King. I'm delighted to welcome you to our annual lectures taking place during World Glaucoma Week. We've got two fantastic speakers who are coming in very quick succession, and I'm hoping for a lively and engaging Q&A session afterwards. And as I've mentioned, please ask any questions, make this an interactive session. It'll be a lot less prescriptive that way. Again, I want to kick off with a further quick update, a partial repeat of some of the comments I made earlier on about Glaucoma UK and plans for the year ahead, and I'd like to point out that I haven't yet made the mistake of referring to us as the IGA, but I'm sure that will come. We know that there's predicted to be a 31% increase in the number of people living with glaucoma by 2035, and we've been reviewing what we need to do in order to expand our reach and scale up our provision of support services to help people with glaucoma across the UK. We know that the pandemic has had huge impact on people's experiences due to delays with the system, and more people than ever are living with glaucoma. There's a growing number who haven't been diagnosed and treated when they might have been. We want to continue to expand our services and to help more people than ever before, and we'll continue to offer digital and online support in order to reach more people, but we'll continue our face-to-face work too. We've invested in the staff team, expanded our regional capacity, and added new professional engagement colleagues. We're going to start doing a consultation to identify what it is that people want in the face-to-face as opposed to digital sessions. You know that care is going remote for many in many forums, which has many advantages but potentially some disadvantages. There'll be an article about this in an upcoming issue of Insight magazine, as well as information in focus about the consultation. We really want the views of everyone to make sure that our post-COVID face-to-face sessions are effective and provide people with the services they want. We all plan to undertake a review of our research strategy to ensure that we continue to invest in high-quality studies into the causes, detection, care and treatment of glaucoma so that we can improve the lives of people with glaucoma in the future. I mentioned briefly that our immediate past CEO, Karen Osborne, left us in January. I'd like to thank her for everything she did in the 5 years she was at the helm. She had a particularly torrid last 2 years, but I thought she dealt with that, as did the rest of the team, with extraordinary poise and success. I'm delighted to introduce our new CEO, Joanne Crichton, who's joined us today and starts with us after Easter. Welcome, Joanne. And of course, thanks again to Claire, who's our interim, who's also with us and has curated today's meeting. I'd also like to mention the consultation last year when we asked members about moving from a membership model to an association model. As you know, the proposals received a lot of support, but there was a lot of discussion and some concerns were voiced about the low response rate. So the trustees decided to defer a decision until 2023 to allow time for further review and consultation with you all. This will be one of the areas that Joanne will be picking up soon after she starts in the role. If you feel you'd like to comment on this, further to any other comments you may have made in the past, please do get in contact with the team and they'd be happy to interact with you. Now, I'm delighted to be able to host the Excellence in Glaucoma Care Awards. We feel it's vital to celebrate the wonderful work being done in glaucoma care across the country and the UK, especially in the current challenging times. And so these awards really do recognise those who've made a positive difference. Individuals and teams could be nominated from any field of glaucoma care, and we were delighted that a total of 16 individuals or teams were nominated, demonstrating some fantastically high-quality, excellent work. A panel reviewed all the nominations, and I'm delighted to announce that we have a winner and a runner-up. First of all, I'd like to announce the runner-up. This is Rashmi Matthews from a clinic at Barking of a hospital called Moorfields. This individual received several nominations from her patients, who all described her as going the extra mile and being extremely kind, patient and caring. Well done, Rashmi. Perhaps you'd come up and receive your certificate. I'm delighted to announce the winner. The Cardiff and Vale University Health Board Primary Care Optometry and Secondary Care Glaucoma teams, and Gareth Bulpin, National Architect for Eye Care Digitisation. Gareth is here and he's going to say a few words in accepting the awards. Their work demonstrated true collaboration between optometry high street practices and secondary care consultants by sharing electronic patient records and imaging. During the depths of the COVID pandemic, this collaboration enabled over 2,000 glaucoma patients to be assessed and managed in 2020 to 21, a truly remarkable feat. I'm delighted that Gareth is here to receive the award. Gareth, please come up. Both of you.
First of all, thank you. I know it's like to be a patient. I'm actually had a stroke, lost an eye. So it's on my retirement in 2017. I'm now 68 almost. I had a vision with the minister to actually deliver shared care because as a patient in the hospital, well, I worked for 20 years. I didn't realise the perfect storm was hitting ophthalmic services. I very quickly learned the lesson and started in 2018 with shared care. Shared care meant that working together as a team, we were able to treat more patients the right time, the right place, and timely. So every 3 months, I see my consultant again, and every day I wake up, and one day I might lose the other sight. So for me, I have 6 more months for my 68th birthday to continue the work we're doing. We've advanced from what we did because it's simply not enough. So in 100 days, we created the Teach and Learn Centre. Had to have an official name, sorry. It's called the NHS Wales University Eye Care Centre. And what we've done, we've taken 21 optometrists across Wales to train them at higher certificates, so they can then go back to their practices to actually support the hospitals of Wales. So we opened our, 100 days that happened. So we now look at expanding that and follow on the work that Moorfields has done, to be fair, because why reinvent a wheel? Very good with adults. We're really good at inventing wheels. So we've cut all the tape away and have the pleasure of now my colleague and consultant surgeon, Sin to actually say some words.
Oh, okay. This is very surprising. Hi, I'm Sin, one of the glaucoma consultants in Cardiff and Vale, and actually the only full-time South Wales consultant in glaucoma. We quickly realized that there is a massive backlog. It's a massive amount of people who have glaucoma, but we actually don't know how big a problem it is. And not everyone has glaucoma that we need to see. The consultants don't need to see everyone, but they need to be seen. We need to know, do they need surgery? Do they need treatment? So it's like picking through a needle in a haystack, basically. And we basically used Clayton Street and Moorfields. We used virtual clinics. Started up small, 12 patients. Pandemic hit. And it was like, well, no one can be seen anymore. And that's when we increased it out to Specsavers and all the high street opticians who were still open, surprisingly. They were truly the first front of the line allied health professionals, and they saw all of our glaucoma patients. We saw 1,600 patients. We probably only needed to see 10% of these patients, but basically they were seen and they were treated, and the ones that were really going blind were seen by the consultants and operated on. So that really is the gist of what Gareth was trying to say, that it was a merge and marriage of primary care and secondary care which allowed for this to happen. And we hope to increase it to not just our health board, because what's happening is in South Wales there are 3 health boards, and some are crumbling and some do not have, you know, healthcare professions, and so we are going to expand it. And hearing from Migs and what Hercules project has done, we are hopefully going to copy or duplicate that, because best practice should be shared and should be duplicated so for the patient benefit around all of the UK, basically. So that's what we're doing. Thank you.
Giacomo, thank you.
Thanks. So I'd now like to introduce the first of our 2 speakers. It's a pleasure to introduce someone who needs no introduction. Glaucoma UK Professor of Glaucoma and Allied Studies at UCL, Professor Ted Galway-Heath, is going to tell us what he's been doing in the last 2 years. And I'll tell you, it's going to be a lot.
Great, thank you very much, Philip. So, yeah, this is sort of what I did during lockdown, the sort of stories from my bedroom almost. So, I'm going to start with just outlining the funding that I've got for my research. And of course, top of the list there is the Glaucoma UK funding for the chair. And it represents a substantial investment for Glaucoma UK, and I'm, like Philip, trying not to say IGA because it's taken a lot of practice. It's a substantial investment, and David Sanders talked about good financial management, and what I'm hoping to try and convey this afternoon is that it's a good investment, and that I've been able to leverage funds from other sources to add to those contributed by Glaucoma UK to do research in glaucoma. So there's the chair fund that supports what I do, and then there's a grant for a specific project which relates to mitochondrial function, which has formed the focus of much of what I've been doing over the last few years. The next I'll tell you in more detail is a new grant from the NIHR EME program, which looks at the effectiveness and mechanisms of treatments for glaucoma. I have a couple of PhD studentships from Santon, one working on mitochondrial function and the other on artificial intelligence. And then there's some pending funding coming from a pharmaceutical company, which will largely support the validation of some of the AI work. So the domains that I'll be talking about this afternoon are these 3: mitochondrial-directed treatments for glaucoma, and we've recently been awarded funding from the NIHR for a multi-centre clinical trial to the tune of £1.9 million. And they're actually considering an expression of interest for top-up funding for a further nearly £400,000 to do more mechanistic work around the trial goals. Then visual field testing technology, which has been a long-term interest of mine, that has achieved funding of £1.5 million over the last year or two. And this is a project that's led by Tony Redmond in Cardiff, but we're co-applicants in London. So there are 4 applicants, and I'm one of those. And then the artificial intelligence development with new funding that's pending. So last time, I can't remember if it was last year or the year before, I told you about mitochondrial function and how it was the basis for potential new therapies. So what I'm going to do is give you a bit of a revision on the topic and then an update of where we've got to. So this is a paper that was published a few years ago, and I'm just going to read out one of the introductory paragraphs because it sort of puts in a nutshell where we're at with glaucoma, and that's that currently the only recognized modifiable risk factor for glaucoma is intraocular pressure. And lowering pressure has been shown to be protective even in normal tension glaucoma. So even people who have glaucoma at normal pressure, lowering their pressure further is beneficial. This implies that there are different degrees of susceptibility of the ganglion cells in the retina, those are the nerve cells in the retina, and that high eye pressure is an important inciting factor in the initiation of the process, but it's becoming increasingly apparent that raised pressure is just one of many possible glaucoma instigating insults. So we need to be looking beyond the pressure in the eye. So if we do look at pressure, these are some data from a clinical trial that we published in The Lancet some 6 or 7 years ago now, looking at the extent to which high pressure in the eye explains the rate of loss in the visual field. Now, I've already told you that pressure is the most important risk factor. It's the only modifiable risk factor. But how much of the disease does it explain? Well, if we look at the data and look at the correlation between the pressure in the eye and the rate that the visual field changes, the eye pressure only explains about 8% of the change in the visual field. So there's quite a lot else that we need to be looking for to explain the rest of the change in the visual field. So what other factors? And if you remember that 8%, I'll be coming back to that later when I talk about the mitochondria. So what evidence do we have that other factors might be important? So I've mentioned normal tension glaucoma already. So 40% of people presenting with glaucoma have an eye pressure that's within the normal range. So we can assume that in those people, the susceptibility of those people is greater than those who develop glaucoma at high pressures. We know that glaucoma gets more common as people get older. So what is it about getting older that confers susceptibility? And we know that when we treat people, some people continue to get worse, even though we've treated the pressure and brought it down to a level that we regard as safe. And the figure here is taken from a study in Canada where patients were treated to what we call the target pressure. When we see patients for the first time, we decide on a target for the pressure that we're going to try and lower the pressure to that we think will be safe for that patient. And in doing that, still, after 7 years, 40% of people can be identified as getting worse. So they must be more susceptible in some way. And when we're talking about getting worse, typically this is what we're thinking about. This is the visual field test, which all glaucoma patients will be woefully familiar with, pressing that button every 4, 6, 12 months. You have to sit there for 10 minutes or more. And what we do when we're sitting at the desk in the clinic is take the results of those visual field tests from each time they've been done, plot them, and run a line through them to see if they're stable or, in this case, getting worse over time. So when I talk about glaucoma worsening, this is really what I'm talking about. And this was just illustrating another clinical trial that was headed up at Moorfields. This is the LIGHT study that was headed by Gus Gazzard, where we were comparing two primary treatments for people diagnosed with glaucoma or ocular hypertension, and that was laser, selective laser trabeculoplasty, or medicine, so laser or drops. And people were treated to target pressure. So every participant that presented, the clinician said, well, I want your pressure to be X, and they were treated until the pressure got to X. And then we looked to see whether or not patients were still getting worse over the course of follow-up. And this is showing that a proportion of subjects, I thought I'd highlighted it here, but there's about 16% of patients in the laser-treated group and 20% in the medicine-treated group were still getting worse after 3 years, despite achieving their target pressures. So this, again, speaks to the susceptibility of people, of different patients, to the level of pressure. So in order to talk about these other risk factors, I need to give you a little overview of what I call the anatomy of glaucoma. So in the retina, you have photoreceptors that are the cells in the retina that respond to light stimuli. They're connected to what we call retinal ganglion cells via an intermediary cell. And the retinal ganglion cells send nerve fibers to the brain. So they connect the light-sensitive cells to the brain. And it's these retinal ganglion cells that are the cells that are damaged in glaucoma. And we believe that the area of damage mostly occurs at the optic nerve head, which is where the nerve fibers collect together to leave the eye. Now, if we look at these nerve fibers, we can see that there are lots of these little packets called mitochondria. They're enclosed in their own membrane, they have their own DNA, and they probably arose biologically as external organisms, so like little bacteria, that then invaded cells and became part of them. And these little mitochondria produce the energy that cells need to survive. All the cell functions, making proteins, and particularly in these nerve cells, sending impulses along the nerves. So the retinal ganglion cells are densely packed with these mitochondria, which means they must have a purpose, otherwise they wouldn't be there. So the retinal ganglion cells are very dependent on these mitochondria. There are also giant mitochondria in the cells around the optic nerve head that support the nerve fibers as they leave the eye. So again, this suggests that these cells, these supporting cells, must need a lot of energy from these mitochondria. And we know the first paper at the top there, mitochondrial dysfunction as a cause for optic neuropathies. This is a paper that illustrates that genetic mutations affecting the mitochondria give rise to problems with retinal ganglion cells. So that tells us that if there's a problem with mitochondria, it can be manifest in the retina, in the cells that are important for glaucoma. Now, how can damage occur to these mitochondria? Well, there are many different potential pathways. There are things that can happen in the eye, toxicity from light even, so blue wavelengths of light can harm the mitochondria. Raised pressure can harm the mitochondria. Poor blood supply can harm the mitochondria. So these are all things going on inside the eye. And then there are things that happen generally that can affect the whole body. That's getting older, affects everything, and genetics. So inherited factors can result in poorly functioning mitochondria. So what I've labelled there is target tissue. These are the things happening in the eye, are difficult to measure in patients because we can't take a biopsy of the optic nerve and see how the mitochondria are doing in the optic nerve, because that would be too invasive. So we have to look elsewhere. So in general, we can look at these generalized or systemic factors that might be influencing mitochondrial function. So what about aging? Well, this is a study that looked at the effect of getting older on the function of mitochondria measured in white blood cells from an ordinary blood test. And the graph that you can see there on the left is from an instrument that we use called a seahorse analyzer, which measures the function of the mitochondria. And the function you can see in the light grey for older subjects is below that of the black, younger subjects. So this is showing us that the function of these mitochondria is lower in people who are older compared to younger subjects. And these are people without glaucoma. So this is a naturally occurring fact of life. What about the genes? Well, this is a very nice study done by one of my colleagues at Moorfields, Anthony Kawaja, which looked at gene sets related to mitochondrial function and looked to see if these sets of genes were associated with the presence of glaucoma. So these are the mitochondrial gene sets that they looked at relating to different functions of the mitochondria. And he looked to see if they were related to normal tension glaucoma, high tension glaucoma, or glaucoma as a whole. So the carbohydrate metabolism gene set was related to normal tension glaucoma. The lipid metabolism gene set related to both normal tension glaucoma and glaucoma as a whole. And the other one, called nucleotide metabolism, related to glaucoma as a whole. So this is genetic evidence that there are genes related to mitochondrial function that are also associated with the presence of glaucoma. So what about real evidence from patients? So directly measuring mitochondrial function in people with glaucoma. Well, the first study that I'm aware of that did this came from Saudi Arabia and is shown here. And on the vertical axis, we've got the mitochondrial function. And then you've got healthy subjects versus patients with open-angle glaucoma. And you can see that on average, people with glaucoma have lower mitochondrial function compared to people without glaucoma. Similar studies have been done elsewhere. This was from Jonathan Croston's lab when he was in Melbourne, identifying that a particular enzyme system related to mitochondria was particularly affected in people with glaucoma. And then we've got new data from my own group at Moorfields, where we've taken 30 age-similar people without glaucoma and compared the mitochondrial function with 69 patients with high-pressure glaucoma and nearly 100 patients with normal pressure glaucoma, and looked to see how the mitochondrial function compares. And you can see here that patients with high-pressure glaucoma have lower mitochondrial function compared to the healthy subjects, and the normal tension glaucoma patients have lower mitochondrial function still. So this is really suggesting that this might be an important susceptibility factor. So the next question is, well, how does mitochondrial function affect getting worse? So if you already have glaucoma, does it matter what your mitochondrial function is? The answer is that yes, it does. So again, we're looking at this rate of change of the visual field over time. And in these same patients, looking at the mitochondrial function and looking to see if it relates to the rate at which the visual field gets worse. And these are all people with glaucoma treated with pressure lowering, as we do as part of normal routine in the clinic. So they're all treated with pressure lowering drops or surgery. This is a table of statistics, so I'm not going to bore you with all of it. Basically, there are 4 different measurements we can take from the seahorse that measure mitochondrial function, and they all show the same thing. So I'm just going to concentrate on one of them. And this is the basal oxygen consumption from the mitochondria. And we looked at various factors that might explain the rate of the visual field getting worse: the age of the patient, the pressure in the eye, and the corneal thickness, as well as the mitochondrial function. And the only one which was statistically significant was the mitochondrial function, showing that it's a really important factor for follow-up, predicting which patients might need more intensive treatment. And this is the plot of the rates of visual field loss against the mitochondrial function. And here's this magic 8% again. 8% of the variability in the rate of visual field loss is explained by the mitochondrial function. That's the same as pressure. So we've got another factor here which might be as important as the pressure in the eye. So the next question you'll all be asking yourself is, can we do anything about it? Can we improve mitochondrial function? Well, we might be able to. So this diagram here shows the importance of vitamin B3 in the production of energy by mitochondria. So we've got at the top there the vitamin B3 pills. They're, through various enzymes in the cells, they create this molecule called NAD, and the NAD is required for the production of another molecule called ATP. And it's that ATP which is the energy molecule that the cells need for all the cellular functions. So this nicotinamide might be quite important. Is nicotinamide deficient in people with glaucoma? Well, there's only one study that's looked at this so far, and it was done in France. And lo and behold, they found that nicotinamide levels in people with glaucoma is lower than that in people without glaucoma. So the next question is, if we try and replace that nicotinamide, does that boost mitochondrial function, and does that help the glaucoma process? So the first person to look at this is Jonathan Croston again, when he was in Melbourne, and he gave people with glaucoma a high dose of nicotinamide or a placebo, which is a sugar pill. And he looked to see whether after 3 months, people with glaucoma and the high-dose nicotinamide, was their vision better than that in people taking the sugar pill? And they found that it was. Small differences, but there was a slight improvement in visual function in glaucoma patients taking the high-dose nicotinamide, vitamin B3. Both, the middle panel is showing what we call electrophysiology. That's a measure of the electrical activity in the eye from stimulating the eye with light. And the panel on the right is showing the conventional visual field test, showing the same result, a slight improvement in vision. And this actually has been repeated by a group in New York now, and they found the same thing. So it looks like nicotinamide might be able to improve visual function a little bit. So the next question is, what about preserving vision over the longer period? So if we give people with glaucoma high doses of nicotinamide, does that stop the visual field from getting worse over time? So we've been awarded funding from the NIHR for a clinical trial to look at this. And it's again what we call a placebo-controlled study, where half the patients will get high-dose nicotinamide, half will get a sugar pill. They'll all be treated for pressure lowering. And at the end of each participant will be in the study for 2 years, and we'll look at the end of 2 years to see whether or not the patients on the high-dose nicotinamide have done better than those on the sugar pill. So that's due to finish in 2026, so I'm afraid you'll have to wait a little bit for the answer from this trial, but it's very exciting, and I'm very pleased that Kate Lees is here this afternoon, who's in charge of the patient advisory group for this clinical trial. So we'll have lots of input from participants and patients with glaucoma into the design and conduct of the trial and transmitting the outcome when we get the results. The research team behind this study is shown here. This is really the research team for the laboratory studies. Gerasimos was my PhD student 7 years ago. He did a PhD with me and Anthony Shapira, who's head of the clinical neurosciences at UCL up at the Royal Free. And we've now got another PhD student that we share with David Chow, called Bledi Petritti, who's done the nice work that I showed you in those graphs earlier. And we're also collaborating with Pete Williams, who came from Cardiff, then he went to the States, and now he's in Sweden, and he's done a lot of what we call the preclinical models, the rat and mouse models of glaucoma, showing that nicotinamide works in rats and mice to prevent glaucoma. So that's the first topic. The next is visual field technology. And actually, I'm just thinking there's a lot of Cardiff connection here this afternoon. So I wasn't aware that we'd have a Cardiff representation in the audience. So this work, as I'll show you in a few slides' time, is being led from Cardiff. And it's all about improving the technology that we use for visual field testing. Our big problem with visual fields is they're very variable. This is a series of visual fields from a lady with glaucoma, and you can see that it seems to be worse on occasions, better on some occasions, then worse again. And what we have to do in clinic is work out whether or not that series is stable or getting worse. And you can see around this line that we've drawn through the visual fields, there's a lot of variability around that line, which makes it difficult to be sure whether a patient is getting worse or not. So one of the things that we can do is look at the way the visual field is done. Now this is technical stuff, looking at the way that we measure the sensitivity of the retina with the visual field test. So here we're showing that the response that a patient makes in a visual field test is related to the size of the stimulus that we present and the brightness of the stimulus. So in general, this line above here are people with glaucoma. They're less sensitive to light flashes. That's why that line is above. And it's shifted to the right. So the way that we test the visual field is either in conventional visual field testing, is by taking a single size of stimulus and making it brighter or dimmer. So that's what I'm showing in C2 there, the stimulus getting brighter, the stimulus stays the same size. Another way of doing it would be to use a smaller stimulus and make it brighter, or we could use a stimulus that has the same intensity all the time and just make it bigger. Or we could do a combination of the two, make it bigger and brighter. And then we can look to see which of those is associated with the least variability, the least imprecision. So we did this and found that the stimulus that is the most reliable, if you like, with the highest what we call signal-to-noise ratio, that's the biggest signal for the least amount of variability, was in fact this stimulus that varies only in size. So it looks like we'll be better off doing a visual field test where we vary the size of the stimulus, not the one that we've all been doing for the last 50 years, where it just varies in brightness. I can see some looks of despair in the audience. Don't worry, we can convert the results of your old visual field test into the new one once we've developed it. So Tony Redmond, as I mentioned, has been leading this and attracted £1.5 million in funding to further develop this concept. And the research team here is Tony, who did his PhD with Roger Anderson and me some years ago, probably 7 years ago as well, and Paudie Mulholland, who is a lecturer in Ulster, and he did his PhD with Tony and me. So you can see there's a bit of a theme there. We look after our own. So the last thing that I'm going to talk about is a bit of artificial intelligence, which I hope will sort of lay the ground for peers who I can't see yet in the audience, but he's coming after the tea break. Excellent. So, okay, righto. Okay, probably at his laptop, doing some amazing AI work while we speak. So this is a little bit of AI work, artificial intelligence, predicting the visual field from OCT images. So many of you have probably had images taken of your nerves in the clinic, and it's a lot less arduous than sitting there pressing a button when you think you may have seen a light. So if we can take a picture of the nerve, can we predict what the visual field would look like so that you don't have to do that visual field test so often? So it's back to this question, why would we want to do this? Well, it's down to the variability, again, that there is in the visual field. If we can supplement these data with something that's more reliable, from a nice reproducible picture of the nerve, we may be able to tell if people are stable or getting worse with greater accuracy. So can imaging augment visual field testing to improve precision? So what we do at the moment is we do a visual field test and we do a picture and we put the results side by side and we say to ourselves, well, I look at this one, that may be getting worse, that one looks like it's stable, and we try and put it together in our heads, which isn't a very efficient way of doing it. So there must be better ways. And the idea behind this better way is to say, okay, it's difficult putting an image and a visual field together. What if we change that image into a visual field and then put it side by side with the real field? We then can combine them and hopefully know what's going on a little better. So our research question is, can we use artificial intelligence to predict the visual field from an OCT image? OCT is one of these imaging devices that we use in the clinic. using state-of-the-art machine learning and the current state-of-the-art for OCT imaging. Now, when we do these sorts of studies, we need two data sets that are independent from each other. Because if you develop an algorithm on one data set and test it on the same data set, it's bound to do well because it's already seen the data, so it'll do the same thing and it'll do very well. So we have to have an independent data set, which I'm calling here the test data set, to test the algorithm that was trained on the first data set. And I'll show you that our test data set was quite special for these purposes. It was a test, what we call a test-retest data set, where happy participants did the visual field test 10 times in the space of 3 months. And the reason for asking them to do that was, again, because of this variability. Because each test varies from the one before and after, if you do 10, you can take an average and know what the real test should have looked like. So how do we evaluate the model? Well, we take those 10 visual fields, stack them together like that, and take the average. And then we can look to see how our AI is doing various different ways. So we can compare the OCT with one visual field to see how our prediction from an image compares with one visual field from the series. Or better, we can say, how does that prediction compare with the average of those 10 visual fields? Because that's closer to the truth. We call it the best available estimate. Or for reference, we can say, well, how does a single visual field compare with that average visual field? So if you take one visual field, how good is that at predicting the average? So this is the performance of the single OCT predicting a single visual field. And what I'm showing you here is what we call box plots. So the smaller the box, the more accurate the prediction. So you can see on the right, which is where the visual field is nearly normal, the OCT is really quite accurate in predicting the visual field. But where the visual field becomes abnormal, the box is bigger, less accuracy. So there's much less accuracy towards the bottom. But it's a little bit better when we ask the OCT to predict the average of the visual fields. So if you like, the true visual field. Here the boxes are a bit smaller, but we've still got that variability. So the real question, I think, that we need to keep in mind is, how does that compare with the visual field, what we do now? So how well the visual field predicts the true visual field? Well, that looks like that. So yes, the visual field is still better than the OCT, but the OCT isn't doing badly. So what we need to do now is validate this in the next study. Now, we've published these data. These came out just in January. So what we need to do is validate this, and that's the funding that I said was pending from a pharmaceutical company. Well, why a pharmaceutical company? Well, they do clinical trials, and they want quick answers. So they want accurate measurements of patients' visual function over time. So our next study will be to convert the OCT into a visual field in a series taken over time to look to see if that gives us more accurate predictions. That's the research team. Now, these are all really cool guys because they're not English. Yorgos is Greek, and he's doing his viva for his PhD next Thursday, so good luck to him. Giovanni is a clinical glaucoma fellow at Moorfields, but he's the most amazing data whiz, and you can see he's also quite cool in his sunglasses there. And the other Giovanni is also Italian and also a data whiz who works at City University with David Crabb. And they form a really great team, such a great team they've actually formed a company, and they'll be charging me for the research that they'll be doing in the next phase. Thank you for your attention.
Thanks, Ed. So we are scheduled for a tea break now, which I'm going to recommend that we take. Pierce will be speaking afterwards, and then there'll be the Q&A. And I'm going to suggest that the many questions of Ted concerning his talk can be addressed in the Q&A, if that's all right. So thanks for your attention. Cup of tea. I think we're due to be back at 3:15, so let's try and get back just before that. Thank you very much. Brilliant. Thanks. Thanks, everyone. If you could perhaps take your seats again. So it's a great pleasure to meet to introduce our second keynote speaker, Professor Piers Keane from the Moorfields DeepMind collaboration, who's going to talk about code to clinic, I believe. Piers.
Thank you for the introduction, and thank you for the invitation to come and speak here, and Winnie and Glaucoma UK for asking me to speak. I feel slightly out of place here. I'm not a glaucoma specialist. I'm a medical retina specialist at Moorfields, but hopefully still have some interesting things to tell you about. So the title of the presentation is the Moorfield DeepMind collaboration going from code to clinic. And I'm going to tell you a little bit about the work that we've done with this collaboration between Moorfields Eye Hospital and the artificial intelligence company DeepMind. And some of you may have heard me talk about this, particularly before the pandemic. And for those of you who have, it'll be, I hope, interesting to get an update on how things have progressed since you last heard about this. The other thing, just to say a little bit more about my background. So I wear a number of different hats. So the first is that I'm a consultant, as I've just said, in the medical retina service at Moorfields Eye Hospital. So I specialize in the treatment of retinal diseases like age-related macular degeneration, diabetic eye disease, and some of the other commonest causes of blindness in the UK. The other thing is that I'm a professor of artificial medical intelligence at Institute of Ophthalmology at University College London. And so although I'm not a computer scientist and I'm not an engineer, I've somehow come to find myself leading a multidisciplinary clinical research group that aims to develop and apply AI in healthcare. And one of the things that we believe is that ophthalmology is at the forefront of developing artificial intelligence in healthcare and can be an exemplar for other medical specialties in the transformation that I believe and hope is going to come in the coming years. The other thing that I should acknowledge is my funders. So I'm in a very fortunate position that I'm funded by UK Research and Innovation as a Future Leaders Fellow. And that means that I'm in a very nice position where 80% of my time is protected for research. So I do 1 day of clinic per week, and the rest of the time I'm in meetings and doing research and doing all of that good stuff. And the focus of UKRI, as the name suggests, is not just on the research, but also the innovation related to the research. So for us, it's very much not just about producing scientific papers, but actually seeing how we can translate the learnings from those papers into patient benefit in the longer term. And then the other thing that I'm going to tell you is I do have some financial disclosures. And probably the most important for you to know about, particularly if I get particularly enthusiastic over the course of the next 30, 40 minutes, is that I have previously acted as a consultant for the artificial intelligence company DeepMind. So just bear that in mind. So I thought I'd talk you through 3 different things. So the first third of the talk is related to the title, which would be the Moorfields DeepMind collaboration. The second, or the middle third rather, of the talk is going to be about something that came from the Moorfields DeepMind collaboration, but isn't directly linked with DeepMind or with Google or any of those things. And that's something that we're working on called the Insight Health Data Research Hub for eye health. And while a lot of our initial focus has been on retinal disease, I'm very hopeful that in the coming years that this is infrastructure that could lead to huge benefits for patients with glaucoma. And huge benefits not just for Moorfields, but for the UK and for the NHS as a whole. And so I'll tell you a little bit more about that. And then the last thing that I'll tell you about is something that we're very, very excited about, that my friend Alistair Denniston has coined a new term for, which is called oculomics. And this is kind of taking an idea that's more than 100 years old, but taking it to the next level using artificial intelligence, And it's the idea that we can use the eye as a window to the rest of the body. So maybe there's a future where you can go to your local optometrist, have a retinal scan done, and it might be able to say, you're a smoker, you need to stop smoking, or your cholesterol is high, you need to do something about that, or maybe predict whether you're likely to have a stroke or develop dementia or other things like that. And so I'll tell you a little bit about that as well. So why did I establish the collaboration between Moorfields and DeepMind? And why do we need artificial intelligence and new technologies and innovation in ophthalmology, in glaucoma, and in healthcare as a whole? Well, it's not just because it lets us publish nice papers, and it's not just because it's the latest kind of hyped up, exciting new area, but it's really because of these challenges that we face. And I'm preaching to the converted here. Everybody in this room knows just how busy eye clinics around the UK and around the world are, but you may not know that since 2017, ophthalmology has overtaken orthopedics as the #1 busiest of all the medical specialties in England in terms of clinic appointments. So nearly 10% of all clinic appointments in the NHS are for eyes. And that's nearly 10 million appointments per year. And furthermore, that has grown by 37.6% in the last 5 years. So if you look at ophthalmology over the last 5 years, number of appointments going up like this. Look at orthopedics in second place, and it's like this. Now, the brutal truth then, and maybe this is not a nice way to describe it, but we're drowning in the number of patients that we need to see. And the fact is that there are people who lose sight with glaucoma, with other retinal disease, with other eye problems because of delays in being seen and treated. And in fact, even those patients who are seen and treated in a timely fashion, often the experience that they have in our clinics is not optimal in terms of the amount of interaction that they can have with the team that's looking after them. So what I believe is that artificial intelligence and new technology can help, at least in part, to address those issues. And I'm by no means someone who believes that this is something that will just solve all of these problems, because a lot of these challenges are bigger than just one easy solution. But nevertheless, it may mitigate against some of the challenges that we currently have. So why is everybody so excited about AI in the last few years? Well, this is an article that I really like, a long read from the New York Times in December 2016, and they called it The Great AI Awakening. And essentially what this article talks about is that over the last decade, a subset of AI called machine learning, and in fact a subset of machine learning called deep learning, has begun to transform the tech industry. And in fact, the 5 largest companies in the world, Amazon, Apple, Microsoft, Google, and Facebook, in the last decade have pivoted to become AI-first companies. In fact, artificial intelligence, deep learning, machine learning is central to all the devices, the computers that we use, the smartphones that we use, etc. So, in fact, in 2015, Scientific American listed deep learning as one of their world-changing ideas of the year. So this is not just about better smartphones or self-driving cars. This is actually suggesting that there's a potential for a new age of scientific discovery facilitated by this technique called deep learning. Now, more recently, so in the last 5 or more years, we've started to see deep learning move out of the tech industry and into the healthcare setting, and actually also in parallel into the life sciences, the biomedical sciences field. And we're starting to see it in things like prediction of protein folding and nuclear fusion and other things. But in healthcare, one of the first papers that came out was in 2017, one of the first kind of seminal papers, and this came out in Nature in 2017. And essentially, it was on the cover of Nature. It says, "Lesions learnt, AI powers detection of skin cancer findings." So what they did in this paper, a group from Stanford in California, they got about 130,000 photographs of skin lesions. And some of those were cancerous and some of those were benign skin lesions. And they trained a deep learning network, an artificial neural network is what it's called, to be able to tell the difference between benign and malignant on these retinal photographs. And then they tested it separately on a different test set and asked it to predict whether the lesions were benign or malignant. And then they got 20 US-trained, board-certified dermatologists and asked them to say whether the lesions were benign or malignant. And the ground truth was what was the biopsy result in those cases. And the exciting thing was that the AI system did as good or better than those dermatologists. Now, think about what are the implications of that for the dermatologists, for ophthalmologists, for healthcare, and most importantly, for patients. Now, I think it's very exciting, but just to say, before I get too swept up in the hype around this thing, there's lots and lots of caveats about what I've just said. And in fact, these AI systems are not yet actually being used a number of years later in this setting, reflecting the amount of work that's required to translate these things. So what about in ophthalmology? Well, actually the year before the Stanford dermatology paper, probably one of the most important papers in AI came out in JAMA in 2016. And this is from a team in California from Google Brain. And essentially what they did was they developed a deep learning system to try to do automated diabetic retinopathy screening. So what they did was they got hundreds of thousands of retinal photographs from patients with diabetes, and they trained a neural network, a deep learning network, to be able to look at those photographs and simply just make a decision, does this have referable or non-referable diabetic retinopathy? And they showed the effectiveness of this approach and published this as a proof of concept in 2016. Now, why can I say that ophthalmology is at the forefront of AI in healthcare? Well, of course, as an ophthalmologist, I'm hugely biased in this regard. But the fact of the matter is we do have some kind of objective evidence in that in 2018, the FDA gave the first ever approval for an entirely autonomous AI system, and this was for diabetic retinopathy screening. And this is for a company called IDX, or Digital Diagnostics. So that's the first ever FDA-approved autonomous AI system. And that system is now actually available and beginning to be used in the US and in other countries, and potentially in the UK in the near future. And then in fact, the second autonomous AI system ever approved by the FDA was in August 2020, also for diabetic retinopathy, from a company called iNuke. In fact, there's a proliferation of other diabetic retinopathy screening tools that have started to become CE marked and potentially MHRA approved. So we're starting to see that move to the next phase. Although I think it's still fair to say that it isn't yet in widespread global use for a variety of reasons. So where do we come in? Where does Moorfields come in? So in July 2016, we initiated a collaboration between Moorfields and the artificial intelligence company DeepMind. Now, DeepMind are a company that probably a lot of you are familiar with, but a company founded in 2012. And two of the three co-founders are graduates of UCL, and 2 of the 3 co-founders are from London, and they're based in London, so based in King's Cross. And so they got a lot of attention because in 2014, they were acquired by Google, reputedly for £400 million. And they're still based now in 2022 in King's Cross, and they have more than 1,000 of the world's leading AI researchers. So they're arguably the world's leading artificial intelligence company. And just in the past few months, they've announced a lot of breakthroughs in areas such as AI for drug discovery and for nuclear fusion and for climate, prediction of the weather and a number of other things. So really, really exciting what they're doing. So we approached them back in 2015, 2016, and essentially what we've been working on with them is, could we use retinal OCT scans, these optical coherence tomography scans, these high resolution scans of the macular region of the eye, could we work with them to develop a deep learning system that could automatically triage and diagnose those scans, such that suppose you go to your high street optician and you've got some visual symptoms, that you have an OCT scan done, and it will identify those people with the most sight-threatening retinal disease and get them in front of a retinal specialist or get them into the hospital service in the most timely fashion. So that was 2016. Now, alongside that, one of the things that we did in Moorfields is that we shared with them about 1.2 million anonymized historical OCT scans from Moorfields in order to co-develop this artificial intelligence system. And so you can imagine that that's a massive undertaking, both from a technical perspective, but also from the perspective of sharing NHS data with an industry partner, particularly when that industry partner is owned by a big tech company such as Google. So we had to put a lot of effort into data protection, information governance, ethical approvals, patient and public involvement and engagement in order to try and do that right. So in any event, fast forward to August 2018, and excitingly, we're able to publish the first research output from that collaboration, which we published in the journal Nature Medicine in 2018. And you can see there's more than 30 different co-authors on the paper. And this just reflects the fact that it was a real multidisciplinary collaboration. So it involved clinical expertise from world-leading ophthalmologists from Moorfields, scientists from UCL, and computer scientists and engineers from DeepMind. Now, it was also really exciting that it was featured on the cover of Nature Medicine. And then, of course, this being AI, you can't escape the hype around it. And so it was quite thrilling in some ways that it got lots of global media attention. And so, you know, as someone who, prior to this, had published quite a few papers, which I really put my heart and my soul into publishing, but were probably read by like 5 people, it was really kind of nice to have that kind of attention. On the other hand, it was also a bit awkward because of this hype around AI. And you see these headlines, "Save the sight of millions of people." Well, in 2022, a number of years later, how many people's sight do you think we've saved with this system? 0. 0 so far. And in fact, the system, people, if you send me an email after this talk and you say, "Can I come and see the AI running in Moorfields?" I say, well, actually, it's not quite there yet. We're still working on this process. And I'll tell you a little bit more of the reasons for that in a moment. So it's really this question of you have to be careful in balancing the kind of enthusiasm and excitement for these technologies, but also with the reality of translating them. So let me just show you one example of the algorithm in action. This is running on an OCT scan from a patient in their 40s with very poorly controlled diabetes. And it's a bit complicated, but on the lower row, what you see is we feed in the raw OCT scan into the system, and then we have two neural networks in the system, so deep learning networks, and the first of the networks is a segmentation network. And so what that means is that we've trained it to delineate all the disease features on the scan. So in this case, it's delineating all the swelling of the retina, the macular edema. That then feeds into a second neural network called a classification network, and that makes the diagnosis and the triage decision. So on the top left here, maybe a little bit hard to read on these slides, but it gives a referral suggestion. So in this case, it's saying semi-urgent referral to a retina specialist. And then it's giving a diagnosis probability. And in this case, it's saying macular edema, 98.5% certainty. So, where are we now in 2022 with this system? Well, I thought I'd tell you a little anecdote about this guy. This is a guy called Ken Cukier. And Ken is a senior editor at The Economist who's based here in London, who's written about the work that we've done at Moorfields, and so I happened to come to know him through that work. And so last year, in one of the lockdowns, I can't remember which one it was, but in one of the lockdowns, he calls me on a Saturday morning and he says, I've lost sight in my left eye. What should I do? And so essentially I talked him through going into Moorfields emergency department, and he got seen and he got treated and he got looked after. But while he was there, I think he was kind of nervous, and he was, but also kind of interested in AI and the technologies and things like that. So while he was there, he kept asking the nurses and the doctors every step of the way, where's this AI system that I was writing about, and that was world-leading AI system, and they were like thinking like, what's he talking about? And so a few days later, he put out this message on Twitter, which I'll show you in a second, which was meant to be kind of gently teasing me and teasing us about the situation. So he said, AI is a fraud. I went to Moorfields for emergency eye surgery, and instead of DeepMind's cool algorithms diagnosing me and robot surgeons, I had to accept the excellent, skilled, thoughtful care of human medical staff. What a disappointment! Exclamation mark. Now, as it happened, the condition that he had was not something that we would diagnose on OCT. So the AI wouldn't have helped even if it was ready, but nevertheless, it was kind of a nice point that he made. And in fact, he very kindly invited me to come on his podcast and tell him about the challenges of going from code to clinic with these AI systems. And I'm teasing him slightly because he's a brilliant supporter of our work. So where's the challenge here with this? Well, the issue is that there's this thing that we call the AI chasm. And this is a term that we borrowed from the tech world. And in the tech world, it's the idea that if you're a tech startup and you're raising some venture capital funding to develop your AI tool for mobile phones or something like that, that it's one thing to do a cool demo and raise some money, but it's a very different thing to have something that can be deployed at scale around the world. And if you've got an AI chasm in the tech world, you can imagine how broad that is in healthcare, with all of the other challenges and regulatory approvals and other things that are required. So what are those challenges? Well, the first of these is around technical maturity. So, as a clinician, I have to confess that I was a bit clueless about this sort of thing, even until just a few years ago. So the AI system that you describe in a research paper, that's just like a piece of experimental code that works as a kind of, for a research paper, but that's in no way something that can be used as a proper commercial software product and used by people safely all around the world. And so one of the things we've been doing since we published the paper is actually taking the model that we created and rewriting it from the ground up so that it could run in a fraction of the time with a fraction of the computing power. And so just before the pandemic, we actually did a live demo at the Crick Institute at Wired Health with a patient of ours with age-related macular degeneration. We did a live demo in front of all this audience to demonstrate this newer, more technically mature version of the algorithm we had developed. And so the analogy I would use is the research paper is a bit like you're trying to break the world land speed record, and you develop a prototype car, and you've got a team of like 30 engineers, and you make a record-breaking attempt, and you beat the land speed record. And what we're trying to do now is actually make a production car that can actually be used without all those engineers at hand, safely and cheaply by people all around the world. So the next big issue then is, you know, we published a paper showing it kind of works, it looks good, but that's in a retrospective study. Is that actually going to work in the real world? And so one of the things we've been working on for the last couple of years is a global validation study. And so we want to prove that an algorithm that has been developed in more fields won't just work on like sort of white Irish, you know, middle-aged man, but also will work on a patient with diabetes in Ghana, or a patient with macular degeneration in Brazil, or in Mexico, or in the US, or in many other regions and countries around the world. And so we're hoping to publish the results of that global validation study a little bit later this year. But as you can imagine, that's been a Herculean task to bring together you know, clinics and data from all around the world, and not just the usual suspects in terms of eye hospitals. So you've got your clinical validation, you've got a technically mature algorithm. Well, the next big blocker is you need regulatory approval. You need FDA approval, or you need MHRA approval, or CE marking. And the reality is that could require 6,000 to 7,000 pages of documents, and sort of $1 to $10 million in cost, and minimum 18 months in time to be able to get something like that. And the reality is that that's not something that is possible from a kind of NHS setting. That's something that you need to work with people, with industry partners that have expertise to do that sort of thing. And then you get your FDA approval. Well, what are you going to do then? Well, who's going to pay for it? So are you going to have NICE approval? In the US, are you going to have Medicare and Medicaid approval? And if they approve it, at what level are they going to pay for it? Because if they set the tariffs too low, then maybe it doesn't become economically viable. And are private insurers going to pay for it, particularly in private systems like in the US? So all of these challenges, and if that wasn't depressing enough, you've got people have agreed to pay for it. Will doctors and other healthcare professionals actually use it? Or will patients accept it? So there's all these questions we have. And so the exciting thing on a more positive note is that, you know, Moorfields is building a new hospital, you know, in the King's Cross area of London. And so we're already thinking about how we can have the flexibility in the design of the hospital so we can take advantage of the new pathways of care that we think artificial intelligence will allow in the coming decade. But really what we're excited about is the potential of deep learning to bring world-leading expertise out of specialized hospitals into the community and potentially into the home of patients in the future to relieve the burden of chronic eye disease, whether it's retinal disease or glaucoma or other things. And so we think there's a real opportunity here, both in the UK and more broadly. And part of that is because all the major optometry chains now are adopting OCT. You may have seen this advertising campaign from Specsavers, but of course it's not just Specsavers. All of the major chains are adopting it, and indeed independent optometrists also adopting OCT. And it's pretty common now for friends or family members to go for an eye test and have an OCT scan done and email me asking me questions about it after they've had it done. So really exciting potential. Now in the last 13 minutes or so, I'm just going to tell you about two other things. And the first of these is the Insight Hub. And just to say, this is something that has come from what we've learned in the Moorfields DeepMind collaboration. So essentially, because of the expertise that we began to develop in the technical infrastructure, but just as importantly, or more importantly, in the governance and the ethical approvals around big data and AI, we were very fortunate in October 2019 to receive significant funding from Health Data Research UK to form Insight, the Health Data Research Hub for eye health. And we have a really multi-sector team involved with Insight. It's 2 NHS trusts, so University Hospitals Birmingham and Moorfields. We have industry partners such as Roche and Google. We have the charity partner, which is Action Against AMD, and a number of other supporting institutions. So for example, we work with the Open Data Institute, based here in London, which is founded by Sir Tim Berners-Lee, who is the inventor of the World Wide Web. And the director of the hub is my good friend and collaborator, Professor Alistair Denniston, who's a consultant in Birmingham. Now, I'm not going to go into a lot of details about Insight, but what's exciting is that we've built a cloud-based data pipeline that has more than 25 million ophthalmic images just from Moorfields and from Birmingham. And we already think that that is, we think, by far the world's largest ophthalmic imaging bioresource. So in particular, we think that this is an order of magnitude bigger than any similar resource in the United States. And that's by virtue of the size of Moorfields, the size of Birmingham, and the way that the NHS is set up. And we've built very sophisticated analytics layer on top of that. And I won't go into the details of this, but suffice to say that what we can do is use that infrastructure to create anonymized subsets of the data upon which we can do research and develop potentially state-of-the-art AI tools. But also we can use this data infrastructure to help with direct patient care. So potentially helping with clinical trial recruitment, helping with clinical audit, service improvement, and many, many other things. Now, the focus of the thing that I've just shown you, this is all about, intravitreal injections for macular degeneration and so on. But we're also beginning to incorporate glaucoma-related data, visual acuity, intraocular pressure measurements, imaging results, and beginning to work with people like Ted and Anthony Kawaja and others about seeing how this infrastructure can facilitate a lot of the cutting edge that these glaucoma specialists are doing. So the next steps are, well, what we think of is we're interested in discovery, innovation, and care. So discovery is, can we do AI-assisted gain AI-assisted scientific insights? Innovation is, can we take it from a research paper to actually something that's being used in patients? And care is around actual delivery, health service delivery, implementation at scale. So just in the last few minutes, I want to just tell you about another cool thing, which is also as a result of the experience that we developed with the collaboration between Moorfields and DeepMind. And so this is this idea that with AI we can potentially use the eye as a window to the rest of the body. And of course, as I said, we've known this for more than 100 years, that you could see signs of anemia or diabetes or high blood pressure in the eye. But the exciting thing is now, with AI, with big data, with advanced imaging, we can potentially take it to the next level. So there's been papers just in the last two or 3 years which have shown that with deep learning, it's possible to look at a retinal photograph like this and say, this is a woman. Not something that a human expert can do, by the way. And with deep learning, it's possible to say, she's 58 years old. And with deep learning, we can say whether she smokes or not. And with deep learning, we can say whether she's diabetic or not. And with deep learning, we can give an estimate of her body mass index and an estimate of her blood pressure. And there's lots of other evidence that there's other more powerful signals hidden within the eye examination that we may be able to unlock with AI. So why is that the case? Is this some kind of magic, or is there some kind of plausible rationale for this? Well, the fact of the matter is that with the eye, with the retina, it's one of the only places the only place in the body where you can directly visualize a microvascular tissue. And not only that, it's famously described as being an approachable part of the brain. So the retina is the only part of the central nervous system that you can directly visualize without cutting a hole in someone's head and lifting off their skull to look inside. And in fact, we've known this for quite a while. And so there's lots of work done by people like Tien Wang and others, which shows that the arteriovenous crossing points or focal narrowing of the vessels can be predictive of stroke and things like heart attack and cardiovascular disease. But in fact, there's increasing evidence that it may also predict neurodegenerative disease, in particular dementia and Alzheimer's disease. And so lots of papers in recent years. One of them that's pretty cool from Rotterdam, from a big study in the Netherlands called the Rotterdam study. And essentially in this study, they did OCT scans on all the participants in the study. And in that study, 86 patients who had these scans went on to develop dementia. And then what they found was, and this would be very familiar to glaucoma specialists, is that thinning of the inner layers of the retina, particularly the retinal nerve fiber layer, was actually associated with the subsequent development of dementia and in some cases Alzheimer's disease. Now, this was a kind of exciting finding, but it was also relatively weak finding given the small numbers of incident cases, even in a large study such as the Rotterdam study. So we've coined the term oculomics to say that actually maybe we can take it to the next level by combining advanced imaging, big data, and deep learning. And so Alistair Denston, who I've talked about, was the one who coined this term, and we wrote about it in a publication just to kind of try and lock it in the public imagination, just published in the last year or two. And so that fed into this thing that we were developing at Moorfields called the ALTS-I study. So again, because of our experience on governance and data protection and how to dealing with large data sets, we got this idea. Could we take data from every patient aged over the age of 40 years at Moorfields, and could we take all their images over a 10-year period and link it with the national database called HES, which is Hospital Episode Statistic. This is a national database of every inpatient and outpatient and emergency department admission in the country. So if you had a patient who had an eye scan done at Moorfields, we could link their anonymized photo, and if they moved to a different part of the country and had a heart attack or developed Parkinson's or a stroke or something like that, we would be able to make that linkage. So we've been working on that for a number of years, and what was exciting was when we made the linkage, we got some really powerful numbers. So we found that over 350,000 patients linked with more than 1.3 million admission episodes. and we had over 6 million retinal scans in that. And then in terms of the incident systemic disease, we found that nearly 10,000 patients who had retinal imaging at Moorfields who went on to develop a stroke. Now, by comparison, in UK Biobank, we had about 700 patients who had retinal imaging who went on to develop a stroke. In terms of heart attacks, we had about 12,000 incident cases. And in UK Biobank, they had about 900, or just under 1,000 incident cases. And then in terms of dementia, we've got 13,000 incident cases. And in UK Biobank, they had about 250 cases with retinal imaging who went on to develop a stroke. Now, those are the big hitters, but actually we know every cardiovascular and neurodegenerative and systemic disease that these patients have gone on to develop. So, for example, could be schizophrenia, multiple sclerosis, Parkinson's disease, leukemia, COPD, Huntington's disease, you name it, we have information about that linkage. In terms of the imaging involved, over nearly 2 million retinal photographs and 1.3 million OCT volume scans. So what we're excited about is really unleashing the power of artificial intelligence to investigate this, because there isn't any other data set in the world that's like this. Now, you may be interested in the funding for this. Well, UK Biobank, I'm sure a lot of you will have heard of UK Biobank. Funding for UK Biobank, £244 million, probably even more than that, to be honest. So how much do you think we funded the ALSI study for? £15,000. We got a small grant from Fight for Sight and Alzheimer's Research UK to fund this. So I call it Biobank on a shoestring. Now, what's the catch? Well, what I haven't told you about is the timelines associated with this. And so what we've gone through actually began with an idea that I had in May 2017. And it took us 4 to 5 years to get all the permissions to make all those linkages. And that's permissions at all different levels from all different institutions to get to that point. But we had the experience and the grit to get through that. But it speaks to me of the potential of the UK's data as we can get systems in place to be able to kind of capitalize on that in a quicker but equally responsible sort of way. Just to say, if anybody's interested in learning a little bit more about it, because of our attention to detail on information governance, The Economist wrote about us in December 2019. And it's only now in 2022, after 5 or more years, that we're actually starting the scientific experiments. So hopefully you're going to be excited in the next year or two to tell you a little bit more about that. And so the next steps are, we want to link it with primary care data, we want to extend it to other parts of the country, and lots of other cool stuff. And just to highlight that the person who's really done most of the hard work on this is Siegfried Wagner, who's an ophthalmology trainee at Moorfields doing a PhD with me. And really the exciting thing is this vision that I mentioned earlier, which is maybe in the future you have an eye scan in the community and it tells you a lot more than just whether you've got glaucoma or whether you've got macular degeneration, but it helps you with systemic disease. And that's exciting because a lot of people prefer to go to have an eye test done than they prefer to go to their GP, for example. So my last slide, I promise I've talked too long. I'm not used to giving in-person presentations, so I'm still figuring that out a little bit. But I hope over the last 40 minutes, I've begun to convince you, with appropriate levels of caution and caveats and skepticism, that there is this huge potential of artificial intelligence to fundamentally transform the way that we do eye examination, and hopefully reinvent the eye examination for the 21st century. And then lastly, if anyone would like to get in touch with me, that's my email address. Thank you very much.
Thank you very much. Could I ask Ted and the rest of the panel, that's Winnie, Cecilia, Sue, come and join us. Look like we've got. Come in. We do have enough chairs, but one is going to have to be perched, I'm afraid. Yeah, well, there's only 7 of us because sadly Roshni can't be with us. Yes, I think that's everyone. Yeah, it'd be great to have a roving mic in the audience. So, our popular Q&A session. We have up to 5 o'clock. Tony's been given 15 minutes to finish off the session, and I don't think he needs the whole 15 minutes. So I think we can use the best part of the time until 5 o'clock. So any questions from the floor, either on of Ted or Pierce on their talks, or indeed on any aspect of glaucoma, research, support, clinical aspects that you'd like to discuss? We have one question here. Thank you. And perhaps you just briefly say who you are and perhaps where you're from.
Okay, I'm Celia Locks, I'm from London, and great talks, thank you. 2 questions. You were saying you obviously can't do invasive research. Do you want our eyes when we die, basically? And question number 2 is vitamin B3. If we're not on this study, should we be buying vitamin B3 tablets? And if I could also ask Professor Keane, how many participants were there in the biobank study? And are you saying that there's a link between glaucoma and, say, Alzheimer's or dementia?
Thank you very much. So if I might suggest that Tony fields the first question, do we want your eyes? Ted fields the second one about vitamin B3, and clearly Pierce for the third. Tony.
Yes. That's the answer.
So how do we give them to you?
Don't know, but we can contact you and let you know. Okay.
Well, actually, now you have to opt out so unless you opt out as an organ donor, there's a high likelihood that we will get your eyes.
But you want your eyes to go to research, is that what you're saying?
Well, I think I've got quite interesting eyes, and possibly we all have here, I don't know. So I would like them to be of use to people in the future with glaucoma.
So we've been light-hearted. Ted, perhaps you'd address that and the vitamin B3 issue as well.
Yeah, certainly. So, I mean, this actually goes back quite a bit, because there was a time, I think, when the IGA was the IGA, that we did actually talk about trying to set up a system, because one of the problems is getting donated eyes to the lab in time, because they need to be fresh for us to be able to do the experiments, the invasive experiments on them. And that's actually quite challenging. And it really ground to a bit of a halt. And I think it's probably worth trying to look at again. I mean, many donated organs will go for medical applications. So if you donate an eye, the cornea will get used as a donor cornea for someone who needs a new cornea. But we need to make sure that the rest of the eye goes to research appropriately. And it's a question of setting that up and making sure that the eyes get to the labs in the right time.
Before we go to the B3, in fact, we did get 2 questions asked in advance, and one of them is slightly irrelevant. The question is there any research into using any tissue other than human tissue for corneal transplant? So, Ted, do you want to briefly say anything about that?
For corneal transplant, not really my field, but the answer is yes, people are looking at biomaterials. and using biomaterials and stem cells that are converted into cells that make corneal tissue. So yes, there is research going on in that field, but I don't know quite how far.
And there are clinical applications now. There are prostheses for corneas which are implanted at various centres, including Moorfields, for very badly damaged eyes when there's no alternative. And that involves plastics, not allergenic tissue, not tissue from other species, but certainly artificial biomaterials. Ted, do you want to say something about the vitamin B3 issue?
Yeah, so B3 at home, not yet. And I say that for a number of reasons. One is that we don't yet have the evidence that it works. So there are experiments that have been done in rats and mice that shows that it works in rats and mice, but that we're not rats and mice, we're people. And we have to prove it in people beforehand. And the dose in the trial is very high dose, not what you would get in a vitamin supplement bottle from the high street. And before recommending that people take a high dose of something for an extended period of time, we've got to be really sure that it's also safe. And that's one of the aspects of a clinical trial, is that you monitor for safety of an intervention. So we were discussing this earlier, whether or not any of us have talked about vitamin B3 in high dose for our patients. And after a discussion with patients saying, well, we don't yet have the evidence, we believe it to be fairly safe, but we don't have the big safety data yet. If you would like to, this is the dose that you would need to take. But we don't wholesale recommend it. No, not yet.
And Piers, the question about the numbers in your study.
I think the question was around, so UK Biobank enrolled, I believe, 500,000 participants, of which I think 69 or 70,000 underwent the retinal imaging subset. In terms of your other question about links between glaucoma and dementia, probably there's people on the panel that are better able to answer that than I am, but I'm not particularly aware of any strong evidence that suggests that if you have glaucoma, that you're more likely to develop Alzheimer's. But I would definitely defer to everybody on the panel about that.
Yeah, I mean, in the literature, there's evidence saying yes and evidence saying no. So I think the jury's out. I mean, there's unlikely to be a strong relationship, otherwise the evidence in the literature would be quite clear. But so far as I'm aware, and I mean, correct me if I'm wrong, what I've read is that there are some publishing yes, some publishing no. And what happens often in scientific literature is there's what we call a publication bias. So people publish positive results and don't publish negative results. So if we're seeing some published negative results as well as some published positive results, it's likely there are a lot more studies that have got negative results that haven't published.
Good afternoon, thank you. Dennis Smith from Croydon with the group over there as well. Following on from vitamin B3, when I was first diagnosed in 2005, it was recommended that I took B12 for normal tension glaucoma. Now, is that still the case? And if so, what is the recommended dosage, please? Thank you.
I'm afraid it's going to be Ted again.
You want me to
isn't
feel
it?
that one as well? Again, no hard evidence that vitamin B12 supplementation is good for glaucoma. Deficiencies of some vitamins can lead to what we call optic neuropathies. So if we identify people that are already deficient in certain vitamins, then taking supplements is useful. But if you've got normal levels of those vitamins, then there's no evidence that supplementing them is helpful. What the dose is, I haven't a clue. I think.
Usually by injection, isn't it?
Is it?
We don't.
Right, yeah.
Yeah.
Yeah, ask your GP.
Another question. Teresa.
Yeah, hi, Teresa Borsick. Thank you very much. Fantastic talks, actually. I might have missed it. Can you easily measure the mitochondrial function, or will you be able to in the future Will it be like a visual fields test?
That's a really great question. There are two places where we'd like to be able to, one where we would like to be able to measure mitochondrial function, but we can't in a living person, and the other is where we can do it. So we can at the moment already measure it from white blood cells, just from an ordinary blood test, but you need specialised equipment to do that, and not many places have it. So, for instance, the Institute of Ophthalmology has only just bought one, and there are two in the Institute of Neurology at UCL, and UCL is one of the biggest universities in the world, so it's not widespread equipment at all. But it is technically feasible to do that. But where we really want to be able to measure mitochondrial function is in the eye, because not only may mitochondria not be functioning well for systemic generalized reasons, but they may not be functioning well because of particular insults in the eye. There are imaging devices which can measure the difference between two states of a particular molecule that's important in the energy transfer within cells, but that'll give us absolute amounts in the eye. But if you've got a condition where some cells have been lost, you don't know whether or not the remaining cells have got the right amount of that molecule, or whether or not they're depleted. And also you don't know where in the eye that signal's coming from. We want to be able to measure in particular cells. So Moorfields has just appointed a new professor of advanced ocular imaging. So I've said to him, over to you. This is this is on my shopping list.
Yeah. Tim Axon, London. Another question for Ted. You quoted a figure of 8% variability in sight loss resulting from IOP, from pressure. That's a remarkably small percentage, intuitively. How does that translate into terms of treatment? I mean, how effective is reduction of pressure in terms of sight loss?
Again, that's another really good question. So the answer to the second part of your question is it's really effective. It's the 8% of the pressure measurement explains the change in the visual field over time. The reason it's only 8% is a number of reasons. One is because of the differential susceptibility in different people. So one person may get worse if the pressure's 20, but another person may get worse if the pressure's 15. So if you just measure the pressure, the link between that pressure measurement and getting worse isn't that strong. But if you take that pressure of 15 and make it 10, that person will stop getting worse. So that explains why a treatment works, but the link with the actual pressure measurement isn't so great. And the other reason that the percentage that explains the amount of worsening is so low is because of the variability that there is in the data. Because the visual field can be getting worse, but we may not know it's getting worse because it's lost in all that measurement variability. And the same with the pressure. It's a very variable measurement. So we've got two very variable measurements, trying to get one to explain the other. You end up with not a very strong relationship between the two.
David, our esteemed treasurer.
Creating some exercise for crossing the room. Yes, Dave Sanders from Kent, I guess. My question's for Professor Pierce Keane. I was quite interested in this statistic about the number of appointments. And I think you used the word overtaken, that ophthalmologists, well, anyway, people looking for help with their eyesight, that has overtaken orthopedic, I think you said, which indicates a trend. Otherwise, it may always have been like that. I think you said it had overtaken. So can you say any more about that? What do you think are the real issues behind that? You know, is it's supply and demand, or is it that people are, that there's a lot more expectation maybe about eyesight these days, that more people are dissatisfied and they're coming more with questions about their eyesight, or is there an increase in infections, diseases, and so on? Can you say any more about what you think is happening in society?
So I think the answer that I'll give will definitely be reflects my professional background in terms of retinal disease. So two things I would say first are the main reasons, and then maybe I'll add one other point. So the fact is that with an aging population, we see a massive incidence of aging-related diseases such as age-related macular degeneration, AMD. And so there was a study that came out in the British Journal of Ophthalmology in 2019 from a German group led by a guy called Frank Holz. And they looked at the epidemiology of AMD in Europe, where they tried to estimate the prevalence of AMD across Europe. And when I read these studies, my eyes gloss over a little bit because they always mention like big numbers and it always sounds very impressive. But there was one number that caught my eye in the abstract of that paper, where they said they estimate that 25% of those aged 60 and over in Europe have early or intermediate forms of AMD. That's 25%. And 60 is not that old. That's massive numbers. So that's just one disease and driving a huge number of patients that are seen in the NHS. And then the second big disease from my own specialty of retina would be diabetes, and the increased prevalence of diabetes in the population, and particularly in other countries, low and middle income countries around the world, as they start to become more developed, then we have to deal with those diseases. My third point, which is perhaps a little bit less important, but just to say, but touches on something that you mentioned, around more people coming in or more people being aware or things like that. So I think that having OCT scans in the community is a very good thing, but it is a sort of a very powerful imaging modality which is being used, and the people using it don't always have a lot of training or expertise in interpreting the scans. And it's a bit like giving an MRI scanner to every GP in the country and just telling them, do an MRI on everybody who comes in with a headache or a cough, but not giving them a lot of the ability to interpret that. So we do get a huge amount of false positive referrals. So just to tell you, to make that concrete, in 2016 in Moorfields, we had 7,000 urgent new patient referrals as possible wet AMD, the blinding form of this condition. And of those 7,000, only 800 patients actually had wet AMD. And so we could probably use AI to help better triage and prioritize those patients.
Another question? David Parkin.
David Parkins, I'm an optometrist. I've also been involved in data looking from Public Health England in terms of the HES data. And the Vision Atlas that was published last year actually looked at the number of total attendances, looked at the number of new attendances. And out of the 9 million that was actually total ophthalmology attendances, there was 2.2 million firsts. And also the data that says that only 3.4 million people were responsible for those 9 million attendances. And that means that there's a lot less people in the system, but they're having multiple attendances, multiple first attendances, and multiple follow-up attendances. So in terms of the numbers being seen in the future, it's about clinical practice that's prompted this in terms of multiple appointments and multiple injections in terms of A&D. But traditionally, there's been an issue with multiple appointments for people with glaucoma over time. And so that was first recognized in 2009 when the NPSA alert came in about the delays in follow-up. So this is not new in that sense. But I'm just asking, many of the treatments require multiple attendances each year by a smaller number of people, which is driving the activity for ophthalmology in general. It's not necessarily number of people that have risen, it's actually the clinical practice. So in terms of the future, we need to change clinical practice, and that may be through AI and looking at risk assessments of patients who need to be seen more frequently. And that certainly COVID has done that. But I think in terms of the way that we organize services, this needs to be very carefully done, because obviously you're not necessarily going to see your consultant each time. You may see a series of tests, and that may be done remotely. So I think there's a whole system of things that might need to change in order to deliver services, but they're not going to be the same in the future. And I point that to Pierce.
I think you gave a better answer to the question than I, or a more nuanced answer. I think I totally agree with that. I don't want to bore you about AMD, but that's my kind of passion. We published work in the last year where we looked at people who got diagnosed with wet AMD and Moorfields back in 2008, just as we were starting to get these new treatments. On average, those people required 56 injections into their eye, and so it's a lifelong treatment in many cases.
There's no way to stop, basically, in that sense. The other data, which they haven't put out yet, but roughly the 3.4 million people is roughly split into first and follow-ups, and that. Then you start to wonder why that data is saying that. So I think we need to look at the data a little bit more, and I fully support the view that data really is the key thing that we need, and the bigger database and the sources that we can get will actually make an evidence-based reason why we do things more. So you know, well done.
You're right that we do need to be more sophisticated in the data we collect. I mean, a lot of the, well, not a lot, but a proportion of the new patient appointments will be old patients who failed to attend their clinic appointments, were discharged and have been re-referred. So we need to be able to get at those data as well. And in terms of the future being patients attending for only tests which are read remotely, that's already happening all around the country. It's the number of patients we're seeing under that sort of model has increased vastly because of COVID, but it was already beginning before that. And patients actually like that because they don't want to sit in clinics waiting 3 hours to see someone for 5 minutes to be told you're fine. What patients want is to have a conversation if there's something that's not going quite right. But if everything's fine, they're happy just to come in and have their tests and go.
Thanks. Sheila.
Sorry, I should have moved to you, Sheila Page. What evidence do you have on these testing and then results later systems? Because having been the victim of one and knowing other victims of them, the idea that a patient likes them to me seems absolutely as wrong-headed as anything could be. First, you don't get the results possibly for some time, in 3 months, according to one case that I've heard. Second, if there is a problem with the results, and I've certainly found sometimes the test doesn't work properly, you would then have to go back. Thirdly, the people doing the test seem to be unsupervised. I'm speaking now of Moorfields, in a way that it was not true in the case of normal clinics. Has there actually been a study of how successful these are and what patients think of them?
Yes, is the answer to that. So, I mean, I don't know if anybody else would like to...
I was going to try and protect Ted from having to answer all
yes,
the questions.
Yeah.
I was going to suggest maybe Celia, who's done some work with NICE, and I know Manchester have a very robust attitude. Perhaps you'd just, rather than saying exactly what's happened at Moorfields, sort of talking about the way that that method of care has been promulgated throughout the country.
Yeah, so we have a very well-established virtual clinic at Manchester. Yeah, so part of setting up that service, we did have patient engagement. That's why we don't call it a virtual clinic. Patients didn't like the term virtual. We actually call it a glaucoma assessment clinic. And we have set up very specific standards. So whilst you say that the people involved in the clinics aren't supervised, we train them to a very high standard so that they can recognise when they have taken a good quality image or not a good quality image, so that it'll be repeated there and then to get the best possible results. It depends on patient selection, so not all patients are suitable for a virtual clinic. However, virtual clinics have given benefit in terms of allowing a lot of patients to be assessed in a very short period of time, particularly with this COVID backlog that we have, so that actually we can identify those people who are running into difficulties. I've heard your experience of not getting the results quickly enough. And again, we've set standards to say that our virtual clinics should be reviewed within 2 weeks. And actually, we communicate directly with the patient rather than the tradition of communication going to the GP with the patient being copied in. So I think that, you know, some people do really enjoy the virtual clinics because they're in and out within a quarter of an hour, and that's very convenient for them. And other people don't. And I think.
My question was not about any of this. It was, has anyone done a study of either the success in terms of clinical outcomes of these clinics or in terms of patient satisfaction?
Yeah, well, we've done audits and we've done patient satisfaction questionnaires, absolutely. Yeah.
And as we have Moorfields as well, extensively. I think the answer to your question is really we need a system that respects all patients' needs. So where it suits a patient, that's absolutely the right pathway, provided we're getting the data quality that we need. Where it doesn't suit a patient, then we need to have a flexible system where those patients can be seen either in a classical face-to-face clinic or an optometry-based clinic where the standards of care are really excellent. So we've got a hybrid system where different pathways can be followed, and also a hybrid in terms that patients needn't necessarily go forever into one pathway or the other. They can flip-flop between.
I hear exactly what you're saying, Sheila. And what's interesting is that a lot of these systems had been developed for many years in many parts of the country, not universally. And in fact, one of our previous trustees, Chris Wall, was particularly vociferous in her dislike of such a system. COVID changed everything in that we had no choice. And it's one of those situations where COVID will leave us better off in some aspects. But I understand there are many consumers, patients, clients, whatever you want to call them, who really like the system, and others who detest it because they like to see someone face-to-face. The sad truth is we can't see everyone face-to-face, nor, probably in my opinion, should we. I was very impressed to hear at Moorfields a huge new initiative, which Winnie might say something about how the standards, the principles are being maintained, and how it's made objective and reproducible and reliable. And arguably, for those of us, I've had such a system in place at one of the clinics I worked in, and my initial thought was it would be a compromise, and I ultimately came to passionately believe that it was a better standard of care than the care that you can sometimes give face-to-face. Winnie, do you want to say something about the...
Yeah, and when we started our technician-led clinics or remote clinics, that it was evaluated. And one of the significant things that came out is many of you who might have attended glaucoma clinics are waiting a long time in the clinic to be seen, and this halved the time that the patient would have to wait and go through the clinic. And certainly, I agree with Phil. It's a very big leap for some patients who are very used to having a personal interaction with their consultant. But I would say, certainly in the setting of the pandemic, it's a far safer way of being seen than having your consultant clinic appointment being permanently moved and moved and moved. So that's what I say to patients. The Hercules project is, I'm not involved with it, but it's taking the concept of these new clinic pathways and undertaking a kind of a research project in a large space, which is Brent Cross Shopping Centre, using a big space there. And it's taking this model of the virtual clinic or the technician clinic, but constantly adapting it based on the findings. So including not just clinicians, architects, experts in movement and patient flow, and constantly adapting the clinic so they can move walls, they can adapt where patients are sitting. And there will be quite a lot of patient interaction and focus on that as well. Anything else to say?
And if I could just add something as well, we run similar clinics in Nottingham. We call them monitoring clinics because they didn't like the word virtual either. And we engaged our patients prior to setting up those clinics, and then we undertook feedback for the first 1,000 patients that we saw, and it was overwhelmingly positive. Most of them were delighted, primarily because they were in and out in 20 minutes and they didn't spend time sitting around waiting for us to see us for 5 minutes. But I think there's also another point. The point is that actually we really need those face-to-face appointments with us for those people who are at risk of going blind, those people who have need surgery or have progressive disease. And thankfully, we are able to do that much better by diverting the patients who don't have that kind of disease to virtual clinics, but with the flexibility to identify if that is occurring and then transfer them into those face-to-face clinics. The volume of patients with glaucoma, and going back to what was said earlier, is only going to increase with an aging population. More people are going to be diagnosed with glaucoma, they're going to live with glaucoma, and they're going to require more follow-up for their glaucoma because they're living longer. So these processes are really adaptive to allow us to manage that as well as we can.
Go ahead, please.
I just wanted to make one quick comment, which just to say, from a retinal perspective, we have these clinics as well, and I think that they're very good and important. But I have to say, I think that there's probably significant room for improvement in some areas, and I think while it's clear to me that they're safe and they're effective, to me the communications with patients probably are a weakness. And actually, just if I think more broadly within the NHS outside of ophthalmology, that's the thing that drives me bananas in terms of our like family interactions. When you're told, you know, go and have an ultrasound, and we'll call you if there's something wrong to worry, and then you don't know whether anybody has looked at it or not, or you have a blood test. We'll let you know if there's something to worry about, and then you never hear anything ever again. So I think definitely we can try and figure out. We should try and figure out how to do things better.
Could I just perhaps introduce Sue as well, who's one of our trustees, who's an optometrist. Now, another option is, of course, not to manage some patients with the disease in a hospital setting, but in a community or optometric setting. Do you want to say something a bit about that, Sue?
Yes, of course, thank you. Yes, optometrists have been co-managing patients for years with various conditions. Glaucoma, I suspect, was one of the first ones, actually, but certainly with macular disease as well. And so we've been doing that in Kent for a very long time with a colleague who's got an OCT and works very closely with the hospital. So for those of you that are seen by an optometrist, I would like to say that they will be working maybe not physically alongside your ophthalmologist, but certainly in conjunction with them. And there will be, and there must be, reporting mechanisms to enable any suspect findings to be reported promptly back to the ophthalmologist, so you can be got back into the hospital if needed. I believe some patients are worried that if they seem to be sort of discharged from the hospital to their optometrist for their ongoing monitoring, they might then get lost in the cracks, and actually really nothing could be further from the truth on that.
Thanks. Ted, you wanted to...
Yeah, I was just going to maybe add with a physical example, Pierce's point of where we might be able to improve, because most of these clinics have been designed to be really slick for AMD or diabetic retinopathy, or really slick for glaucoma. And then you get a patient who comes in and say, well, my cataract's got worse and I can't see so well, and we're not set up to detect that or respond to the patient at that visit. So we really need to develop our systems so that we're able to respond to something that's not actually glaucoma at that glaucoma visit in future, or something, dry eye that needs attention. So we need to adapt in some way to deal with these additional unexpected conditions.
We have another remote question, actually, which was addressed, and that is, while I watch my panel members look at the floor so that I don't catch their eye, is there any connection between stress, good and bad, that makes symptoms worse for glaucoma, but perhaps we might extend that to make the disease more or less progressive? Before I ask if there's anyone on the panel who particularly wants to answer the question, I wonder if there's anyone in the audience who's got experience of something like yoga for glaucoma care. I'm looking actually to someone who mentioned it earlier on, but they're not going to raise their hand. So does anyone... go ahead, sir.
Well, it's recommended on glasses not to do certain exercises.
Not to do them, yes. Certainly if you stand on your head, the intraocular pressure goes up considerably.
They call one the plank, and it was said that this increases the pressures on the eyes, so therefore to avoid it whilst you're doing the Pilates session.
Certainly, absolutely. Activities like that would cause the intraocular pressure to go up. I think the honest truth is no one really knows if well-being is good for the eye, or and conversely stress is bad for the eye. But I know there are those who passionately believe in yoga and lifestyle issues and other forms of meditation. And there's a limited, not very well-reviewed literature that might support that.
While I'm on, could I ask another question not related to this at the moment? Basically, I'm Peter Dolling. I come from Croydon. 2 years ago, I had a XL stent removed from my eye and my right eye, and a micro shunt in place. And basically, afterwards, I was surprised because I'd suffered from double vision for the first time. Now, I mean, this was fine because, to an extent, because the optician was able to remedy this and control it by prisms within my glasses prescription. In time, I suspect that I'm going to have a similar operation on my left eye. And my query is, what's the chances of my double vision getting worse in these instances?
Tony's just published a very excellent paper on surgical treatment of ophthalmology, so he's the obvious person to answer this question.
Punished for publishing. So I think you're unlucky, to be honest with you. If you had is it a Pressiflow microshunt you had, or a Zen? Was that what you said?
An XL Gen stent removed and a microshunt put in.
Fine. So for glaucoma surgery, the most common type of glaucoma surgery giving rise to double vision is when we insert the larger tubes like Bervels or Armids. But it's still quite an unusual side effect. Probably 1 or 2% of people get it. For the other types of glaucoma surgery, it's less likely to occur. And in the studies that you referred to, Phil, of the 250-ish patients who had trabeculectomy, there was one patient who had double vision as a consequence of their surgery. So it's you're unlucky, but there are treatments, as you've alluded to try and overcome that double vision for you, which are clearly working. The chances of you having it in your other eye are still very, double vision as a consequence of surgery in your other eye still remain very slim. I don't think it increases your risk of developing it again.
Jolly good. Thank you very much.
So, vis-à-vis the International Glaucoma Association, I thought I might actually ask Winnie to talk about something that might be relevant to expanding our sphere of influence back from the UK abroad. Winnie?
Thank you, Phil. It's a pleasure to see you all face-to-face. This is my first face-to-face meeting as a trustee. And as well as a consultant in glaucoma, I also have an academic post at the International Centre for Eye Health, which is based at the London School of Hygiene, Tropical Medicine here in London. And my research and the projects I'm focused on with an international team is looking at trying to prevent or reduce the rates of glaucoma blindness in sub-Saharan Africa. They have the highest prevalence of glaucoma in the world. They present late and often blind in one eye, and they present at a younger age. So that's the focus of our research. But at the International Centre of Eye Health, we also have what's called a links program, where links are developed between a unit or an ophthalmology department, often in the UK, and an ophthalmology department in a low or middle income country to provide mutual learning, support, training at all levels of ophthalmic care and for different subspecialties. And so as part of the network that we're building in West Africa, we've been approached to develop a glaucoma link with Moorfields. But also there has been identified a need there to build up their patient support organisations. So for example, in Nigeria, they have quite fledgling patient support organisations in the big cities like, for example, Lagos. And they would like to look at really developing this further. This, I think, would be very helpful for helping manage the disease there. There's a lot of lack of awareness of the disease. There's poor acceptance of treatment, adherence to treatment, and very low acceptance rates of interventions such as surgery. What is being proposed is exploring the option of developing a link between Glaucoma UK and, to start with, about 3 units in Nigeria to try and support them in building up their patient support organisations like we have Glaucoma UK. So that might be to start off with something simple like sharing our resources, our patient education booklets, and maybe then looking at developing the meetings that we have, increasing awareness there, and maybe developing IT support or improved patient access to support. So at the moment, we're just exploring how this might happen, but we have discussed it at the board, and we would value input from the membership as to whether, in theory, they would support an initiative such as this. So I'd be interested to hear people's thoughts, or you can come and talk to me at tea time.
A couple of responses, one here and then one here, if that's okay. It was this lady with the blue cardigan, I think. Yes.
Afternoon, Gwyneth Evans-Patel, Croydon. Thank you very much for all the talks this afternoon. I was particularly interested to see that the scans are used or can be used to look at the whole body as a system. And I think one of the things that you mentioned was blood flow could be, or blood pressure could be seen, or in the scans. And can you recognise low blood pressure and or fluctuating blood flow from those images?
What we've shown, what people have shown at the moment is that you can you can make a good prediction of blood pressure from the retinal photographs. That could be high blood pressure, that could be low blood pressure. It's not, they haven't yet looked at the fluctuations in the blood pressure. And the fact of the matter is, it's still much better and quicker and easier to just put a blood pressure cuff on someone's arm and measure the blood pressure than to apply AI to do it. But it's just more, I guess it was more suggesting that if we can do it, if we can predict it from this, maybe there's even other stuff that we can do that might be stronger and more clinically useful.
May I ask, were you interested because of the potential link between glaucoma and low blood pressure, perhaps treated low blood pressure?
Yes, and particularly fluctuating blood pressure if it drops overnight and the pressure goes up.
And it's well recognised that some forms of glaucoma are exacerbated by fluctuations in blood pressure, and perhaps nocturnal, nighttime low blood pressure or perfusion pressure. Absolutely. And as we know, glaucoma is at least partly a vascular disease, at least some sorts of glaucoma.
Celia Locks again. This is a kind of hazy memory of my optometrist saying some years ago that there was research going on in gene therapy into glaucoma and restoring sight. I'm not sure I've got this right. I can see kind of blankness on the dais.
Well, I mean, experts in genes and glaucoma, and I'm sorry to have to pass this over to Ted. Ted, you're probably more familiar with the experts in particular.
Yes.
May not be your field particularly.
It's not. I'll try to be less hazy than your memory of something your optometrist said. I mean, there are certainly people that are looking at reintroducing genes or introducing genes to correct for incorrectly operating genes in certain eye conditions. A best example is something called Leber's hereditary optic neuropathy, where they're starting gene therapy to prevent an optic neuropathy that's a bit different from glaucoma. But certainly people have been looking at glaucoma. The main problem with glaucoma, though, is that it's almost certainly not a single gene problem. Anthony Kawaja has published that they found over 120 genes contribute to the development of glaucoma. So to give gene therapy to correct something that's got a contribution of a very large number of genes isn't really practical. Genes can be introduced into certain cells to make them produce factors that are good for cells. So we call them trophic factors. So you can put genes into cells to make those factors to support cells in the eye. So it's a different type of gene therapy. Certainly people are looking into that, but I'm not aware of anything that's reaching anything near clinical application yet.
Any other questions? Or do any of the panel want to raise any other issues or make any other comments? Oh, we have another question.
Thank you. It's not a question, but I would just like at the end of the session just to ring the praises of Moorfield's A&E department. I had where are we now, nearly 4 years ago, what you would call an ocular occlusion, which I took very lightly and had to deal with a sense of humour. It so happens that I'm very fortunate that there is absolutely no sign of me having had it now, and I've been told I'm very, very fortunate indeed. However, at the time that I went in, a couple of days after, I realised something was happening to my vision, although I could see everything, but it wasn't. Something was definitely wrong. So I waited from Saturday till Monday because I didn't want to have to go into the overnight bit at an A&E department, and I was ticked off for that. Apparently, I should have got in on the Saturday when I realised something was happening to me. My lightheartedness about it was not appreciated, but the doctor who saw me, as they do in Moorfields, said, I'm going to have a look at your other eye and just check both eyes, which is a normal thing to do. And he said, hang on a minute, I think I might have detected something totally different, unrelated. I'm going to ask another colleague to come and have a look. So the other doctor came in and said, yes, they thought they could both see what they called, I think, a splint, perhaps was it, if I got the right word, in the other eye, totally unrelated to the ocular occlusion. It's something they picked up just by looking at the back of my eye, and that I ought to be referred to the glaucoma clinic. And thank goodness they were what can I say, good at what they were doing, it's not, to have noticed that and to have passed me on to the glaucoma clinic at Moorfields. From that, I learnt, of course, that at the very, very early stages, and this was because they weren't sure whether I had it or I didn't have it and it was in the other eye, it would take probably about 6 months, even if they did know I had glaucoma, it would take at least 6 months to do the relevant tests to see if there was any change that could relate it to glaucoma. And it so happens that they did, and then very soon afterwards it was confirmed that I had glaucoma in the eye and had the ocular occlusion. So that's the background picture. However, I did find that in my experience, ophthalmologists, your local eye testing place who has an ophthalmologist there will do an OCT scan. And now in my case, I've got normal pressure, normal angle, glaucoma. And I'm on 2 sets of drops, day and night, to keep the pressure considerably lower than what was normal and within the normal range. Whatever you, as well, some of you have said you need to get that pressure right down, even well below what one would consider normal. However, the ophthalmologist, in that person's opinion, was convinced I did not have glaucoma, although I had been diagnosed with it at Moorfields. And I thought, well, I knew it was an inexact science, and I knew it's a very difficult science to look into, to study, and you can't be absolutely sure, and you do need somebody from your peer group to give a second or third opinion. How they were convinced that in their opinion, but they said, okay, if you're being treated, it's better to be treated rather than find out some years later that it's a shame you didn't take up the treatment, and actually, yes, you've got full-blown glaucoma. I found from another high street, it was actually Specsavers, but I know that there are concessions, so it's no reflection on them at all. However, they couldn't pick it up either. Now, I knew I had glaucoma at that stage, and when they said, do you have anything, I thought to myself, in any case, I'm going to say no. I just want a simple eye test. I want to have good glasses so I can get on with my life. So I said, no, not as far as I know, no, nothing wrong with my eyes at all. Oh, right, okay, so I got my eye test and I got my glasses. Now, I knew I was lying, but I had a specific reason for lying. I didn't want them to be influenced by the fact that Moorfields had diagnosed glaucoma. Now, I'm 4 years on in my treatment. I'm very, very grateful to Moorfields. I'm grateful to those 2 very young doctors, one backing up the other and saying, yes, there is a possibility, and yes, we think you should be referred to the glaucoma clinic. And for that, I shall be eternally grateful, because 4 years on, I am not aware of any changes in my eyesight at all, other than being a bit older. And so, you know, my glasses for driving need to be adjusted after 2 years or 3 years. But I was just fortunate, but I get the feeling that perhaps the high street, inverted commas, is not necessarily well equipped to diagnose whether a person coming in for an eye test, they've got this lovely machinery, it's very expensive, they do an OCT scan, it looks lovely, it's all got lots of lovely colour indications, and you say, what does it mean? And they say, oh, off the top of their heads. I don't want to be rude, but that's the impression I get. And they can misdiagnose something that years later a person's going to really, really suffer for the rest of their life because nobody picked it up because they had what I've got. Normal tension, a normal angle, glaucoma. Sorry if that sounds a bit long-winded. I'm not very good at putting things precisely.
No, I think that's been very valuable. I think...
But it's a question we've been talking about, diversifying and getting, inverted commas, the high street to take over a lot of the clinical stuff that usually gets shunted into Moorfields or UCL or wherever. I can understand that it's very important because we've got an aging population and we need to deal with the sheer numbers. Apart from the regular updates and visits, as somebody else said, out of so many thousand people, most of those visits were not by new people, but by multiple visits to deal with a minority of people. Yeah. So we do have a huge, huge logistical problem there. Yeah. But they do need to be better educated, perhaps the word is, to use the machinery that they can afford to have in their eye testing, whatever.
Yeah, thanks for that. I think the condition I think that you were mentioning was probably a splinter hemorrhage on the optic nerve.
I've had eye bleeds, and I know they're like, and they're very, very frightening.
We know that that's actually quite a reliable predictor now of the later development of glaucoma, particularly in low-pressure glaucoma. I have to say, I've received a number of very good referrals from optometrists for exactly that reason. So I think if it was a few years ago, it may not be as widely known, but I've been quite impressed by the quality of the referrals from the yes, yeah, and low pressure, as Winnie said, low pressure glaucoma is a difficult diagnosis.
It underlines why you need the artificial intelligence to bring
yes,
right into the high street.
Celia?
A lot more education, and I think that it's very fair to say we have some optometrists here, and increasingly optometrists are taking on additional qualifications. There's additional qualifications in glaucoma, there's additional qualifications for age-related macular degeneration, and so there is that upskilling. Not everyone, of course, but there is that upskilling happening, and we need to encourage that, because we do need their assistance, absolutely.
I thought this was going to turn into a discussion about Moorfields A&E, and I was going to hand over to Winnie, because actually a lot of really interesting changes have happened in Moorfields A&E, which I think are very, again, COVID-driven. Do you want to say something about the remote?
I think I mentioned it last year, but I can go through it again. So Moorfields A&E used to accept any patient individual who walked in, and then a few years ago they started triaging, and then during COVID they set up a remote consultation system called Attend Anywhere, which meant that rather than coming into A&E, the patients could get an appointment by video phone, and the clinician could assess quite a bit from talking to the patient about the history and their symptoms, and also maybe having a look at their eye. Obviously you can't see as much as you can with a slit lamp, but this has worked very well, and it's also used for some of our other specialties. So for example, ocular plastics, so people have lumps on their lids. One of the specialist nurses will do a consultation with them, and she can look at that, and she can actually kind of say, you know, you need surgery or leave it, or you need a biopsy. So these remote consultations comes in all different shapes and sizes, but definitely have helped us through the pandemic and helped develop the services at Moorfields.
I mean, the holy grail would be, of course, a visual field you could do from home on some device, a photograph or imaging taken remotely, perhaps with a smartphone, and then AI to triage and assess the results. And the honest truth is that's probably not that far off, actually, some aspect of that. And so, yeah, that would be the holy grail. Oh, sorry, another question.
Just on that particular point, there is some research going on at the moment from Aberdeen and Belfast and somewhere else, I'm not sure
Nottingham.
Which other centre is, looking at exactly that.
Yes.
Right, okay. And can I also say one other thing? You referring back to the stress factor that may or may not be part of the syndrome or have an effect. Acupuncture is very useful for stress conditions, and I myself have had it a long time ago to see whether it would affect my pressure, which it appeared to do for the short time that I had the acupuncture. And I know there are several studies in Germany and in China looking at acupuncture for glaucoma, with some positive effects. You know, nothing terribly conclusive, but I think it's something worth looking at.
Thank you.
Thank you. Look forward to those results when they come through. Yes, I'm as interested as you are, I can tell you. So I think the time has come now to wrap things up for today. So firstly, I'd like to thank all of you for coming. It's been wonderful to get out and about and to meet face to face again, and certainly makes us feel like there's some normality returning to our opportunity to meet up and discuss things. So thank you all for your excellent questions and input. I'd like to say thank you to our great set of panelists here today. I think I've learned a lot. I've learned a lot about mitochondrial health. Thank you very much, Ted, and how important it is. The question, of course, that we all leave with is, will we be taking vitamin B3 supplements in 10 years' time as part of our routine instead of our glaucoma drops? And we all look forward to finding that out. With the naming study is what you're undertaking. So for all of you who get asked to participate in the naming study, remember this is Ted's study, so you have to participate in it if they approach you in clinic. Okay.
One of the problems is they have to be newly diagnosed patients, so they're not yet in the audience.
So if you know any people who get newly diagnosed with glaucoma over the next few years, tell them what a great guy Ted is and that they need to participate in his study.
And if they happen to be in Nottingham, they can come to your centre.
If they are in Nottingham, they will be asked. So, secondly, and your second talk really nicely merged into Piers's talk, Ted, about the value of OCT and how that may be going to replace potentially visual fields at some stage in the future, which I think a lot of patients would really appreciate. It would be a really innovative change in the way that we manage glaucoma and the experience that patients have when they go to the glaucoma clinic. Piers, where do we start with your talk? It was like a flash forward into the future, a sort of utopian world where actually all we're going to have to do is go to our local optician and have an OCT, and it sounds to me like we will have all of our medical problems perhaps diagnosed at that visit. That would be fantastic, but even from an ophthalmology point of view, it's very exciting, and I really look forward to it. It does sound like we might be in a bit of an AI chasm at the moment, though, so perhaps a little bit longer before we all see that on the high street. But thank you very much for sharing that with us. We've had 2 new trustees today, Cecilia and Roshni, who's not here, so I'd like to welcome those, and it's fantastic that they've agreed to help us over the next few years. And of course, there is one sad note today. We are losing our current chairman, Professor Bloom, who I know you all know very well and value immensely for his fantastic contributions to Glaucoma UK over the last 12 years. I've never heard him described as user-friendly before. However, I think that probably is a really good term that we will remember him as. He has been a breath of fresh air for me and all of us to work with. His ability to manage the organisation, to interact with everybody effectively, to maintain the peace, and to make progress, particularly through COVID, which was a difficult time for everybody, and also through the transition to a new CEO. I think that we're all extremely proud to have worked with him and extremely proud of him. So I wouldn't mind if you would all give him a big round of applause. So it is, of course, traditional to give someone who is leaving the organisation a little something to remember us by. But we know that Phil isn't a very traditional person, so we didn't think it would be important on this occasion. In fact, when we asked around to find out actually what Phil would like, the answer that we got was, what can you buy for somebody who already has everything? So that was actually quite tricky. But apparently the answer is wine. So perhaps we could bring up, oh, it's here. That sneaked in. So Phil, on behalf of all of us, I would like to say a very big thank you. Glaucoma UK will be immensely grateful to your contribution. I'm not going to take these out of the box because apparently this is really expensive stuff.
That's very kind.
And I hope you like it. And this is something to put it in.
Fabulous.
And apparently we're all coming around to your house now to drink it.
Thank you. Well, it has been an honour and a privilege. Thank you very much.
Pleasure.
Thank you all.
And on that note, I look forward to seeing you all again next year. Thank you for coming.
Thank you. So we could open it now.